Okay, so we're gonna start today with fundamentals, and I'm calling it Python fundamentals because some of the nitty-gritty details are related to the programming environment we're going to be working with. However, what we're actually going to go through is something that, regardless of the programming language, you actually have to go through. So we're going to go through certain basics of how do you import data, how do you work with data. This is where linear algebra is really helpful because that's actually our tool to dealing with and organizing data. And then there's something called input and output. How do I read that data in? How do I print it back out? Then how do I actually work with the data in sort of this framework of linear algebra? Okay. So, and then what are the variables? How are we defining them? What are the sort of types of data I could have? And how do I plot the data? No matter, you can do the most exquisite calculations, but if you don't know how to present them to people in some sort of digestible form, and graphs are sort of much better than big tables of data, then you basically kind of communicate the data and the outcomes, and all the fancy analysis you do can go down the drain. So let's get started. So first, I'm just gonna say a little bit about Python. So what is Python? It's a programming environment. There are multiple others. It is free or so-called open source, meaning that you don't have to pay to use it. You simply download it and implement it. And I hope by now everybody has managed to install Anaconda is the distribution that we're going to work with. And it's so-called modular and extensible. It's free and open source. Anybody can come in and pitch in their contribution and publish it. Okay? And you are welcome to come and use it. That's good and bad. It's sort of a free market of sort, right? So there are certain things that then win over the others. And sometimes modules or these extensions, they kind of live for a short time and they might die out. Okay? So there's sustainability can be an issue, whereas if there is a company monitoring the development of the software, that they're the ones filtering and pushing things forward or pushing things back. So some of it is a little bit free market kind of a thing, but that's actually, I'd say, a good thing because regardless, over the time, things that are good survive and things that are not so good, they don't. Okay? However, you do have to be up for change. But we have to be up for change anyway. How many times a year do we have to update our security systems on computers? There's one update at least a month, right? Regardless of which computer you have. So things are always kind of changing, and we have to simply work with that. Again, the choice of programming language is not necessarily essential to this course because we're going to be working with basics and just kind of give you a tool to work with the understanding that this tool might change. Nevertheless, we actually decided to make a switch. We used to teach this in MATLAB, and it's still a good choice. And we're going to move to Python because essentially there's a definite uptrend in using Python, and it's actually becoming crucial skill for you to, for instance, land an interview or something like that. So in order to basically reflect current industry trends, we're switching this course to Python. So essentially, once you do finish this course, even though you're essentially a beginner, I do want you to put that on your CV, that you know Python, because it can make a difference. Now, the name is actually from the 70s series Monty Python's Flying Circus. Is anybody aware? Possibly these series predate you, but I do remember them somewhat. And there is two Python versions right now going on. One is Python 2, one is Python 3. We're going to go with Python 3 because that's the one that is going to survive 10 years from now. Okay? So Python 2 is outgoing, and even though there's quite a bit of software still done in Python 2, differences are not huge. But sometimes you can, certain parts of the syntax, particularly print command, is different in Python 2 versus Python 3. So if you see something that is different, then that what we learned in this class, that's probably one of those differences. Okay? There is numerous, and when I say numerous, there's numerous online courses and materials. You're very welcome to go and guide yourself through some of them. Just when you do, I do suggest that you do Python 3 and not Python 2, simply not to confuse yourself. Okay? Not that it's huge difference, but you don't want to end up confused, especially when you're just starting to learn. So it's possibly even before this Anaconda installation that I asked you to, Python is something that is installed on most software. So if you have a terminal or the command line, so on Windows you have a command line, I'm on a Mac, so I have a terminal, I could simply say Python, and now I'm actually in Python environment. And I can start interacting with it. So the way this software works is that you basically type in commands and it's going to try to execute them as you go. This is the simplest way of them all to compute. So I can literally say 2 plus 3. I'm going to say, hey, it's 5. Okay. The simplest way is not very user-friendly. Right? It's kind of dull and boring. It's just this line of commands. It does work remotely if I need to connect remotely to a computer. It's very basic, so it works. But it's kind of too basic, and there are much user-friendlier ways. So we're going to just exit for now and say goodbye to this part, and we're going to use something that is a little prettier. Okay. So we will go to the prettier part, and this is why I actually asked you to install Anaconda. So I'm assuming everybody has installed that already. If not, let me know. So basically, if you start Anaconda Navigator, and if you could please start it, I'll follow in a second, you will get a bunch of environments. The two biggest ones that we're going to use, so Qt console is something similar to that little window console that I just showed you. It's a little better than that. So we're not going to necessarily work with that right now. We're going to use Spider and Jupyter. And we're going to work a little bit in both so you can actually get a flavor of both. Okay? Spider is an environment that works like a lot of computing environments. It's going to have an editor where you can edit the scripts. It's going to have a little command window where you can start them up and run them. And it's going to have a couple of other windows to inspect variables and stuff like that that you open during the program. And it also, you can open files from it. So it has a little browser for files. So it's a standard type of an environment for programming. A lot of them look like that. Jupyter Notebook is something that is a new trend on the block. It works through your browser. Okay? So anybody has a web browser. And it also makes it then easier for you to work. Every computer, most of them right now, have a browser, so everybody can work through a browser, but you can be connected to various machines underneath that. The browser environment will always look the same. So there is a benefit to that. It's more flexible. Okay. And one particular flexibility about it that we're going to rely on is that all of the kind of results as you execute them line up in one file, and that file is extremely easy to give back as a homework, or to give or share otherwise. So it's going to be much easier to create homework. If you work in Spider environment, you kind of have to, a figure opens up, you have to save it as a figure, then you have to put it in a Word document and so forth when you're putting homework together. This way it's going to be much easier to do homework. Okay. So that's why we're going to do both. So let's just to set the expectations straight in this course, you're not going to be an expert programmer after this. You're just going to get a taste of programming. And it's like any other, like keeping fit, it's a skill that you have to maintain throughout your lifetime. And it's going to change, and you're going to have to keep programming in order to be good at it. Okay? And there's always something to learn. I've been programming for more than 20 years. For some of you, more than a lot. So, but again, this summer, I picked up a new skill, Python. So these are things that are continuously changing and that you have to work on. So let's get going. We went through linear algebra review, and today and this week we're going to work with fundamentals. We're going to define variables and arrays, matrix operations, review certain built-in functions that are making it easier for us to work with matrices and arrays, and how to do input, output, and plotting. So objectives of this initial lecture is to actually work with a lot of stuff that is already there. We just have to learn about it. Okay, so we're not going to actually design programs right now on our own that are doing something new. We're actually going to just work with what's there and get used to it. So we're going to create variables and data arrays primarily and manipulate them, okay? And then read them and put them out and plot them in its display. So variables, just as a term, variable, it's a reserved memory with a name and address, okay, where I can store things. So basically when you define it, you give it a name, then the computer knows, that's where I'm going to put this value. And then I can also call into it. It's now in my memory, so I can work with it. The moment I give it a name, I can work with it. Okay? So variables, in variable, they have to have a data type, what it is that I'm storing. And we're going to get into a little more detail of that later. So now I'm just going to touch upon it. But basically, depending on whether I'm storing integer or a real number or text, I have to define a different type because different things are stored differently. Now, computer, ultimately, the only language computer speaks is 0 and 1. They know on and off, that's it. Okay? Now, how we organize these ones and zeros or on and offs is basically the crux of the matter. Everybody has heard about byte. Your memory is in gigabytes, right? So giga is 10 to the 9 bytes. That's essentially how much you can stuff into the current memory of what you can hold into the computer at the very moment. If you're storing data versus if you're working with it, those are two different types of memories. So there are things that are just stored that I can just read in from later, like your music probably goes in gigabytes, then 200 gigabytes somewhere, probably terabytes. Does anybody have a terabyte of music on their system somewhere? Well, terabyte of music you cannot hold into memory all at once, but you can read in and out, in and out. What you can read, store in the memory right now is probably on the order of 8 to 16 gigabytes. That's most of the laptops in this room. Okay. So there's working memory, and typically we define things in working memory and we give it names. So let's open and let's test things out. So in your Anaconda navigator, please open the spider. So this is my Anaconda. So launch it. So this is a development, and it's letting me know there's a new one. I'm just going to ignore it for now. So this is a development environment. So here there are some, this is essentially the editor part. And right now there's something that I've been working at just before. Okay. Here there's basically, I can either get help, I can explore files on my computer and open them up, and I can explore variables. Right now there are no variables in there, okay, because I haven't done anything yet. And here is where I actually interact with the computer, okay. So this is a command line or console. There is a variable / file explorer or help and editor. And then there's up there are certain shortcut things. So once we're going to get through them, so you can actually open files from here as well as save them and so forth. We're going to go through that. One basic thing you need to know is that when we do save files, save them with .py. Okay, so there's a file format. It's really just a text file, but this way you will know that this is a Python script and can be executed as a Python script. Okay? So file formats are there, so you already probably know some of them, like .docx, it's a Word document, right? .exe is an executable in Windows, and so forth. So there is certain agreed upon .pdf is a portable document format, okay, that most of the computers and phones read. So you can quickly open it from any machine anywhere. So there are certain agreed upon formats, and .py is simply a text file, but .py tells us there's a Python script. So that's what we're going to keep up with. Let's try interacting with this a little bit, and we're going to get through variables. So if I write 2 plus 3 like I did previously in that interactive shell, I'm going to still get the same answer, 5. Okay? Have I defined a variable? No. This is just a calculator. It's fleeting memory, so it executed it and forgot about it. Okay? So this 5, neither 2, nor 3, nor 5 are stored, and I cannot go back to them to get them. I can just retype that information in. So if I actually want to store it and then refer to it later, I'm going to give it a name. So let's say that I say A is equal to 2. Okay? Now my A appears in memory. Okay? And I can see, so if you click on Variable Explorer, maybe you haven't clicked on it yet, but if you click on it, you're going to see A shows up there. I have a name, I have a type, int is integer. My size is 1, I have only one integer stored in A for now, and its value is 2. Okay. There is some automatic part. Now, if I want to work with A again, I could just print A. Print of A. And it's going to print 2. By the way, this, whatever I'm typing in, is on your slide, and I did upload the slides. I'm going to be updating this file. It's a pretty large file for Lecture 2, but all of the stuff for today is up to date. So you can find this on the slides. Also, I posted a script, and that script is, whoops, wrong browser, is in code on Canvas, and this lecture2.1.variables.py actually has most of the stuff, or very close to what I'm going to type in. So if you don't get to something, there is a Python script that you can open up, execute again, retype, whatever you do with it. Okay? So again, it's posted for you, but I'm not going to look at it right now. If you download it though, you can open it through the file explorer here. Let's actually do that. So you go to wherever you download it. I will go to wherever it is in my files. So I'm just going to navigate to it. Lectures. Scripts. 2.1.variables.py. So if you download it, you can navigate to it probably in your downloads, wherever your downloads set. For me, it's in one of my folders. And if I open it, So you can either refer to that or to slides or simply watch what I do, whatever is comfortable, and at some point. You will get it, you will go on Canvas in Files, you will see Code subfolder, and in that folder there is Lecture2.1.variables.py. Download that. So again, you will get it from Canvas. It's otherwise, for me, it's sitting in my folder somewhere. Did everybody find it on Canvas? Yeah. Okay. So it's this first one. Download it. I would right now that we're at it, form a folder somewhere in your own documents, not in downloads. Stuff in downloads gets deleted all the time. Okay? So form a folder somewhere on your computer that will be for 310. And in that folder, create a subfolder called code or scripts or Python or something that refers to code in your brain, not mine. And put that script right there. And now that you're at it, form a folder lectures, download the lectures into it, and homework that we're gonna be working on. So organize your little e-life on your computer. You're gonna be grateful that you do that right now. And then as I post stuff, you just file things away into that folder so when you need it, it's there. So this is a suggested list of subfolders, but you can organize it any way it's easier for you to relate to. Okay? Okay. Has everybody downloaded? So if you want to open that file, then go to File Explorer. So click on File Explorer. Okay? And then navigate to it. You click on Download, most likely in Downloads or that subfolder wherever you moved it. Now that depends on where you put it. So then open it from that. Click on that file and open it. And just to get used to this environment, you could have opened it from here too. There would be a little, this is a standard open file little icon. So I could have clicked on that, and also I would get folders to navigate to and open things. So there are always multiple ways to do things. Yeah. Okay, so this is the script, but I'm gonna just keep. I'm going to go back to my variable explorer. So here I toggle between files and variables. Now if I actually choose something interesting happens. If I say B is 7.4, that's not an integer, that's a real number, right? In computer language, it's so-called floating point number. This point is floating, because in scientific notation it can move around. And now when I say B is equal to 7.4, I see that B shows up as a float. So it's a float is a real number in computer language. And it's also size 1 and its value is 7.4. So it seems that based on what I type in, computer kind of switches accordingly. And now we will see that I'm not always good at following my own prescribed files, so I always go off into tangent. I'm going to give you another type of a variable. I'm going to call it a message, and I'm going to say hello, and I'm going to put it in quotation marks. In quotation marks, either double or single, tell Python that this is text. It's something that is human readable. Underneath that, it's really numbers, but computer displays it to us so we can interpret it as text. And you can see that now there's name, message is a string, so-called string. It's another word for text. It's one string and its value is hello. So it's interpreted as text. So these are the 3 types of variables we're going to work with. But let's go back to numbers. So is everybody comfortable? Has everybody typed everything in? Okay. All right. So now that we have numbers, we can do basic things we would expect with those numbers. So basic arithmetic operations, just like on your calculators, are as you would expect them to be. So print a plus b. It's giving us 9.4. Good. We can do basic math. I can also do division. I can do subtraction. I can print that message too. Hello. So there are certain basic things like printing values that we can do. I can also see the types. So here I have a variable explorer. But if I wanted to console to tell me if I didn't have this variable explorer, so this I have thanks to this spider environment, sometimes it's not there, I could also say, hey, print this type of A just to find out what type of variable is that, and it's going to tell me that it's class integer. And I can repeat that for all 3 that I defined. So B will be class float. And I'm not very fast typing. If you put upper arrow, so on your computer, upper arrow, then the previous command will show up. Down arrow, upper arrow. One up will be the one previous. So you can go through history of your commands with upper arrow. Here. My computer is right here. And that way I don't have to retype. I can just delete. So let's say that I want to type message. I delete that A and replace it with message. And that's why I'm faster typing. Is everybody following what I'm saying, or am I speaking Croatian today? No? I'll teach you another language, no time. Sometimes you'll feel like I'm speaking Croatian. All right, so this is class string, so this is string, and that's what I see in Variable Explorer as well. Are we comfortable with the basics? Cool. Okay, so let's just quickly recap where we're at. So basically, if you want to inspect variables, okay, you can do type, that's a function, it's a built-in function that tells you what the type is. And to get things printed, you typically have to say print something. Okay? Here and there, you're going to get a result when you do 2 plus 3. The output of that command is 5 and it's going to get printed to the screen. But sometimes it doesn't, so then you have to enforce it with print. Okay? You can also change the type of some, so if something is integer, it can be changed in place to a real number. We do that in our brain. Computer has to be told to. Okay? Because if I store integers in one way and I store floats in a different way, to do operations between them, I have to translate. Okay? And you can sometimes just say, well, make an integer out of 2.3. Well, the way we make integer out of it is we chop everything that is away from the dot, so it's going to make 2. If I make an integer out of minus 2.8, it's going to, what I'm going to be left with is minus 2. If I make float out of an integer 5, I'm going to still get the similar value, 5.0, but it's going to be treated as a floating point. So these work as long as they make sense. Don't try to make float out of your message hello. Okay? Doesn't make sense logically. Computer will not make sense. Computer will do something. You're just going to get garbage out. Okay? So computers will do stuff. It's just not going to be what you wanted it to be. Okay? So, again, this variable explorer, this is just for you in the slides, allows you to look at things as well. So, variable names should not be confusing. If you name a variable a minus b, it's going to attempt to do operation minus, okay? Or a minus 5 or something of that sort. So don't work in operations into your name variables. Just stick to numerals and letters. If you start with a letter, that's the best. Then after that, you can have a variable named a1. Okay? To start with 1, it might start getting confusing. Is that a number? Is that a name? Okay. So try to stick to something that will avoid confusion. And you shouldn't, if there is a built-in function print, you shouldn't call your name the variable print. Okay? For obvious reasons. You might say, well, how do I know all of the built-ins? You don't. So here and there you will make a mistake. Okay? And computer will do something without telling you what it did. Okay? So that can be source of errors, and we're going to go through source of errors later. That's simply something that is there. Okay? So here and there, it will typically have rules, and it will do whatever you told it to do by overwrite the meaning of print for later, which can be a problematic thing in a program. But that's where fun begins in programming. Okay. So arithmetic operations, we already have done some basic ones. Addition, subtraction, division work just as you would expect them to. One modulo or remainder during the division operation, integer division, is percent sign. Okay? Multiplication is times. This floor division for integers, 5 divided by 2 is 2, right? And the remainder is, you get the percent. And then this one is a little power, is times. And you will see me throughout this semester type in a little hat, because that's what it is in all other programming languages I know. So it's going to take me a moment to correct myself. If you see me typing in 2 little hat, 3, correct me and say, hey, Dr. Pradanovic, 2 to the power. Let's give it a try. So I'm going to practice a little.
What's floor division?
Floor division, so 5 divided by 2 is 2 in integer terms. Only 2 times 2 fits into 5. The rest is remainder, right? Yes, so it's really integer division, right? So if I have 2 to the power of 4, it's 16. And let's say what would happen if I tried to put in what I'm used to from other languages, most other, it's 2 to the 4. Oh, it's actually going to survive. Sometimes it doesn't. So times, apparently it works with 2 to the 4. There was a couple of times when it didn't, so it depends probably on the inputs.
I gave you 6.
You got 6?
Yeah, I gave you 6, not 16.
Oh, it gave me 6. There we go. I was like, why did it work? So who knows what? That's good. I need to check what operations. But a couple of times it bombed on me when I typed in. So it's doing something else. It's certainly not power. Do we see how that can be source of error? And it's essentially a typo, but I could have that in my program, and unknowingly it's giving me a number. 6 is a meaningful number. And sometimes you can't necessarily check all of the numbers that you type in and all of the computation. So this is a possible source of error. Okay. So our next thing to do is learn to manipulate matrices and vectors, because most of the meaningful data, if you think about petroleum engineering, right? Let's think about well logging. So well logging takes a data point every half a foot or 1 foot, depending on how it's done. 1 foot. Sometimes there's data that goes half a foot, so it depends. But most of the time it's 1. So if I'm logging 3,000 feet, I'm going to get 3,000 numbers just for one of the logs. Okay? Let's say neutron porosity. Okay? Then I'm going to do resistivity, then I'm going to get another 3,000 numbers, and so forth. Okay? Those are vectors. Those are vectors in petroleum engineering. The vectors are not those things in linear algebra when you type in 1, 2, 3 when you don't know what to type in. Okay? Those are the simple stuff. That simple stuff to iron the basics out and how to learn the concepts. But the actual vectors you're going to work with are anywhere between 3,000 to 5,000 to 3 million entries long. Matrices are describing your, for instance, permeability in your reservoir. At the simplest possible way, you have aerial information about that. Okay? So it's a big matrix of numbers. And we don't do reservoirs that are 3 by 3, 3 million by 3 million. Okay? So we're going to deal with large data sets, and you have to have an efficient way of reading them in, working with them, and it's linear algebra is that type of tool. Okay? So most of the operations work with matrices and arrays. And we're going to learn how things, so there are things how math thinks about them, and linear algebra was developed way before computers. Okay? And then there's a way how they're implemented in specific programming language. And they're a little bit of a sometimes disconnected. Okay? So we have to work with that because that's how things are. So we're going to also figure out what are the built-in functions that are returning matrices. So if I have to test something, test a concept, and I have to generate myself a fake array of permeabilities that is somewhat similar in range to the permeabilities that I see in my reservoir. Okay? Then I have to, there are functions that can efficiently do that without me typing in every value or reading it in from some data. It might not happen. And you're going to later get to geostatistics. This is a prerequisite for geostatistics. So you're going to learn how you generate these large fields that are similar to the actually measured data, but we don't sometimes have all of the measured data, so we have to come up with the data that is in the given range, and we're going to learn how to do that here. And also we can actually read in the data if you have the data from files on the disk and put it out. Okay? So there is a specific, this is our first module that we're going to work it with. It's called Numerical Python. Or NumPy for short. And this is our efficient linear algebra tool that we're going to base on. So it basically allows Python to do math with arrays, which could be 1D, 2D arrays, and so forth. So every time we want to use any module, in this case it's going to be Python, you're going to first have to install it. You do installation only once. Except that here, Anaconda took care of that for us, which is why I wanted to use it. So we don't have to do a specific installation, you already have it installed. Okay? So that part is good, but if you want to use some tool, as I said, Python is very extensible and there are so many tools out there. And you will likely need to use one of those tools. Then you have to, if you don't have the tool, you have to install it first. You can do so-called pip install NumPy from, there's PIP is the way to install it. So just remember that there is a way to install things that are not there already. Okay, so that's all I want you to take away today. And then we will also, every time we want to use a module, just because it's installed, that doesn't mean that Python carries it in memory and overloads the working we will have to let Python know that we're going to use it. So that is done by so-called import tool. So every time I want to use Python, I'm going to have to let it know, hey, import NumPy. I can just do NumPy, but we often say SNP, so then every possible built-in function that we use from NumPy, we're going to start with np dot. Now that's a little bit of a burden right now. Only until sometimes you will actually want to define your own functions. So sometimes maybe you don't like how addition or some basic operation is working in Python. You want to define your own. Okay? Then I can actually go and define Masha.addition. Okay? So every time I want to call my own, I just preface it with Masha. Right? So in this case, it's actually good to have a way to be modular. Okay? So this is a way to be modular. So if you are a little bit annoyed with writing np dot every time you do something with this library, remember that this is a way to be modular and extensible, and it's ultimately better. So we're going to get used to it. Okay, so these are some just basic commands that you can type in. You can do dir of np. That basically provides you a long list of all of the possible functions here. I really go to Google rather than typing into things to console. There's a lot of information online. Help of np provides help on the entire thing. Or you can actually ask for help on a very specific function. Okay? So if you know that log2, which is logarithm with base 2, from np library, then you're going to say help np.log2. So let's give it a try, just so that you know where to go when you need help. So first things first, I'm going to import NumPy as np. And once I import it here, it's going to be valid for as long as I have these things open. When I close it down, I will have to import it again. Okay. So if I close down Spider, I'll have to do this again. Okay, so now it's imported. Now I can say, hey, directory, this is from directory of np. And this is the, well, there's a lot of them. So you can go through all of the functions that are available here. Okay? Obviously, a lot of them. Okay? So this is just, this is why it's better to actually go to Google for better readability. But if console is everything you got, if you're not online, better than nothing. I can do help of np.log2. So this is logarithm base 2 that is in NumPy. And then I'm going to get, even this can be longish. There are all the possible notes of how to use it. There are examples. Okay? So help in console, it's extensive. Okay? It's a little hard to read. Which, if you're online, do the same thing in Google. Okay? You might want to call it NumPy in that case. Just give me help on NumPy log2, like write in text. Okay? And you're gonna get it. You can also simply go to numpy.org. Okay? So help is always easier to read online. But if you're not online, it is actually available. It's just hard to read. Okay? All right. One more thing before I let you go. So let's just, before we let out, let's create one array. Okay? It's going to be 1D array, C. C equals to np.array, and then there's 4 numbers in a very specific form. So that way you know how to define your first. So C equals to np dot, just give me 1 second. And I'm just going to type in 4 numbers. Okay. I will see that C shows up in the memory here. And if I print it, I'm going to get brackets around it. This is my 1D array. These are my vectors. There is a way to do lists and arrays in the regular Python, not nearly as powerful. I can't do matrix multiplication. So to get access to much more powerful tools, we need NumPy. So in that case, I don't want to even teach you the regular way. This is the way. Okay, so for large data, for big stuff, it's the other way. All right, see you on Wednesday.